What's going on, computer chads? In this video, we're gonna code an AI agent from scratch because in order to be a beast at the highest level, you have to dominate at the lowest level. So we're not gonna use a framework, we're gonna use Anthropic Claude. But aside from that, we're gonna code things from scratch. It's gonna be simple, 130 lines of Python code in one file, and we're gonna run that file. And running that file, we'll be able to talk to the chatbot and it's going to generate its modifications that it would make to a business forecast. And the business application in this video is going to be, we are the Wynn luxury resort hotel and casino on the Las Vegas Strip. We have hotel rooms, we have cleaning services, we have casino security. So those are the three things we're forecasting. But the point of this video is the AI chatbot that the user would talk to once they already have the initial forecast. So we're making an agent that the user can talk to, and it makes changes to the forecast from scratch. Let's get to it.
First, we're going to import the libraries we need. We need OS, we need date time, we need Anthropic. We're going to use the Anthropic LLM, which is Amazon's large language model. We're not really going to use any sort of framework here. We're going to do it low level. It's relatively simple. It's really as simple as I could make it, I think. So here we got the forecast agent class. And most of this file is going to be this class that has just one function for processing messages. But first there's the initialization function. And when it initializes, it's going to initialize with the Anthropic client. And so we need to give it the API key. And what this does is we're going to have an environment file in the same directory as this agent file. So there's going to be a .env file that has this object in it. So what this does, it gets the environment key. I mean, most people watching this video might know this already, but it gets the environment key from that file and it uses it in this file. One other thing it initializes with is a conversation history, which is empty at first because we're going to refer to this when we process messages. But so that there's the initialization function, and then the main function is process message. So it takes a message and it takes current forecast, which initially is no current forecast. We're processing the message with no current forecast just for the sake of the demo. Normally we'll make the current forecast equal to whatever the forecast is, but because this is a standalone demo without it being connected to anything, we're going to have it default to none, because for the demo it's not going to reference any forecast, so it'll just be none. Alright, so this function will process the user message and return adjustments with a detailed explanation. And first, before we create this function, before we finish this function, I just want to leave it as this for now. So that we can we'll go back to this in a moment. First, we're going to create the demo, and that might make it easier to understand what we're doing when we finish this function. And then once we finish this function, we'll be ready to run it. So if you're following along, this should be an easier way to think about it. Like if you're coding as we do, if you're coding with me, you'll find that this is probably an easier way to think about it. So we're going to go down here, we're going to define the demo function. We're going to do a function for the demo. I would say demo agent, but I'm doing demo chatbot just because it's hardly an agent at this point because it's not connected to anything. So I just like to think of this as the chatbot. Yeah. First things first, we're going to check for the API key. Let me just go back up here and copy this. So if there's no key, then we want it to print an error telling us that. And that's that. The rest of this is the main demo. So we're going to define the agent from that class we just started making. So there's the agent. And then in the terminal, we're going to run this demo in the terminal. So first it'll just print that there's a demo happening. And then the way this demo works is it's going to be a while loop. So this loop will run perpetually. This is the demo. This loop is basically the demo. It's going to run perpetually unless we exit the demo. So the demo is going to work with a message. So this is going to show up in the terminal. It's going to say you, and then it's going to give you a chance to type something. So the Python input function allows you to put a typing option in the terminal. So that's what this is. And then it's going to get a result from your message. So the big function here, remember, is process message. So it will process your message. And then we want it to print the response. So the bot generates a response. It generates a result to your message. That's the point of the process message. As we found up here, we return the result. Your message ends up with a result. And so the result, we're going to do more in this function, and you'll understand more as we go on. But the result is going to have a natural language response. And then the result is also going to have a modifications dictionary, which is how the agent is going to change the forecast. And that's going to be the big meat of a lot of this file that we have to type out, is the way that it gets the other part of the result, which is the modifications. So this is the chat. This is basically the basic chat stuff going on. But the actual purpose of this bot is to edit a business forecast. So the main point of the bot's result is not just the natural language response, but it's also the modifications. So this next part of the demo is going to be handling the modifications, and that's really it. So since the demo is not connected to a forecast, we'll just retrieve the would-be forecast modifications. So sometimes there's not any modifications, because if you say something to the chatbot that doesn't constitute an actual modification to the forecast, it's going to know that, and it's not going to have anything to modify. So we're doing an if statement here just to make sure that there's actually something modifying. So if there's modifications in the result, then just for this demo, we'll print a header for the modifications. And then we'll do a for loop through the modifications. This part's annoying to type out. I'll type out like the first line or two, and then I'll fast forward. All right, yeah. These are the modifications. If there are modifications, then all of these will be populated with something. So the metric is the thing we're modifying, because in the forecast, we're forecasting three things for the business. We have the Wynn Luxury Resort Hotel and Casino in Las Vegas at the Las Vegas Strip. So we're forecasting business demand for the Wynn Hotel. We're forecasting rooms, the hotel rooms. We're forecasting cleaning demand, cleaning services. And we're forecasting security, which is the casino security demand. So the metric is rooms or cleaning or security. And then type, we'll see when we finish the process message function, there's a few different types. It's basically just the kind of change it's making to the forecast. The value is what the forecast is being changed to, because ultimately the agent is finding an exact number to change the value to, because it's essentially automating our efforts with editing the forecast completely. So the start date and the end date is the timeline when this change is going to be made to the forecast. So if we have a UFC fight Saturday night, then maybe hotel rooms, cleaning, casino security, maybe all three of those things have to be increased for, Saturday afternoon, evening, night, Sunday morning, like midnight to 4 a.m., maybe even the next day. And if there's a tech convention, Tuesday to Thursday, maybe those days there's a change that happens. And then reason is a natural language. The chatbot is going to generate an explanation for the change it's made. And this helps us track the changes that it's made. Once we've made multiple changes, the reason becomes very useful. It's also useful because that's something the chatbot uses to talk to the person with the application we're making when they talk to the AI. So at the bottom of this file, we're just putting this thing that we always use when we want to run a Python file as the main app, just because we're doing a demo. You probably know this already if you have experience with Python. All right, so this is the whole demo. So we're checking if we have the API key. We're creating the agent, and then this is the chat panel just for the demo and our command prompt or terminal. This is how it's going to look with the U, and then the bot's going to reply. And then the modifications is the intelligence that's happening. In addition to just the regular response, the modifications are what it actually would be doing if there was a forecast that it was connected to. So as soon as we run the demo, this will make more sense, but it'll make more sense too right now when we edit this process message function. And this might take the most time of anything in this code, although it's still not that bad. We're at 50 lines of code. In total, it's like 130 or 150, I think it's going to take. So process message, here we go. The initial part of processing the message is that we have to manage the conversation history. So of course, when the forecast agent initializes, there's a blank history, which makes sense. So every time the forecast agent processes a message, the first thing it does is it adds that message to the conversation history. So for every message, it records the role, and the message it's processing is the user message, us, but also it does record its own messages too. So that's why we want to put role user here, because this message is going to be our message to the chatbot. And then we want to build this conversation context. So the second thing the bot does after adding the newest message to the conversation history is it builds the conversation context. And the way it's going to do that is first splitting the new message apart from any previous messages. So if there's previous messages, then the length of the history is more than 1. And so if there are previous messages, that's basically what this is if there are previous messages, then conversation context So if there are previous messages, then the conversation context is going to show us, it's going to show the chatbot the previous conversation messages. So initially we want to start the context off with this header so that the bot understands what's being said to it. So previous conversation is the header, and then we're going to give it the actual messages. So for every message in the, for all previous messages from the user and from the agent, we're going to add that message, all those messages, line by line. So the first thing we put in the context for each message is the role. And I don't think I've mentioned this before, this \n, just in case you don't already know this, it makes a new line. So that helps us keep things organized for the chatbot so that it understands what's happening. And the role is either going to be user or agent. Just essentially, the conversation context for the bot, it's going to be alternating messages between the user and the agent. And then once we have all of those previous messages logged into the conversation context, we also want another line instructing the chatbot what to do with the conversation context. So the chatbot, if there is a real history, if there are previous messages in the conversation, the chatbot will acknowledge the previous part of the conversation in addition to explaining what the new change is that's making to the forecast. So this way the user talking to the chatbot understands that, or gets confirmation that the chatbot is accounting for previous messages and not just resetting with every new message, because the user is going to visually see their forecast change over time. But if they make a small change and they put in a new message, it's useful for them potentially to like understand that the bot is accounting for previous things. And then it also just gives more confidence to the user to refer to past messages like, oh, you changed this thing as I told you, but let's actually change it more this way. So that's just why we want to put that confirmation in there. Okay. Okay, now comes the big bad boy, the prompt. So yeah, I have this prompt that I've used already, and it works. So we're gonna do this prompt that I have. So you're an AI assistant for Wynn Resort Las Vegas operations forecasting. That is your role bot. Now analyze the user's message about hotel operations and provide recommendations. And then we give it the conversation context. And just to be clear, after the context, we have the double line break here. So we're putting this all in one line just for the neatness of programming it and having it neatly programmed. In my opinion, it's cleaner this way. So we give it the conversation history, and we give the instructions about how to use the conversation history, and then immediately we give it the message from the user. And then what we're going to do next is we give it very explicit instructions about how to reply to the message. First, we're going to give it today's date. The date's very important. And then we're going to give it the forecast period, which is, in this case, we're doing an hourly forecast for 7 days out. So we're going to tell it next 168 hours or 7 days. And then the gist of what it's doing is parsing the user's intent for modifications to rooms, occupancy percentage. The occupancy percentage is the unit of value for rooms. We're doing percentages. And then for cleaning, we have the number of staff, the staff needed. That's the metric for that. And the metric for security is also staff needed. And then we're going to give it examples. So the first example is there's a big UFC fight this Saturday. And we're telling it that, for example, what it would do in response to that is increase rooms to 95% occupancy, increase security staff needed by plus 40%, and increase cleaning staff needed by plus 25%. Second example is convention. The second example is convention Monday morning. Like, for example, there's a big tech convention, AWS reInvent is happening on the Las Vegas Strip. So for this example, we're giving the bot an example of it. Cleaning staff would increase by plus 30%, specifically from 10 a.m. to 2 p.m., and rooms plus 85%. So one difference here, just for a little bit of interesting context, this would mean that cleaning in rooms goes up for convention. Well, this is a Monday morning convention, so that's because Monday morning convention, if it's just Monday morning and that's it, then yeah, maybe you wouldn't need extra security. Even a tech convention, if it's on the weekend, you could imagine the casinos might be a little busier, so maybe you would want extra security. But a big UFC fight, it's like, yeah, the increased room occupancy and cleaning for sure, but then also security, bring that up. Just in general, a UFC fight might bring a different type of crowd. I love UFC though. I'm not obsessed with it or anything, but I like it. I like wrestling. I love wrestling. World X just happened. David Carr beat Mitchell Messenbrink. And also recently, there's a lot of crazy stuff. Oh yeah, PJ Duke beat Yanni. That was crazy. So, and of course we have Captain America beat Gable Stevenson recently. All right, big UFC fight. The thing is, like casinos, like the casinos are probably going to be busy around the UFC fight, so it makes sense for extra security. And then also, people who are professional fighters, there might be other people like challenging them or getting in their way or something. You never know. Extra security makes sense in my opinion. That's just some of the thought behind this. And then another example is pool party season starting. Because, hotels have pools where they have EDM concerts during the day and at night. So pool party season starting, the weather is about perfect around that time. It's like 80 degrees to 90 degrees, nice and sunny. It's not too hot yet in Las Vegas when the season just starts. So we have cleaning. Let's say the rooms are like the same because it's not really people who are staying at the hotel for the pool parties, but the cleaning goes up and security goes up. So we have three different examples right there. And now we have in my opinion, the most interesting thing in this whole file is the way that we format the JSON. And if you recall in the demo, we built this out here where we have this modifications list. So that's what we're going to do now in the process message function is we're going to create that dictionary. So we're going to tell the bot to only reply to messages or only generate a JSON format response. And so the chatbot doesn't directly give its response to the user. We actually have a function that processes the response and it gives the natural language explanation to the user. That's what we'll do right here. So the response is a natural language explanation of the changes in reasoning. So this is what the user is going to see. But the chatbot also generates modifications. Ooh, let's just spell that right. So now we're going to do our list. And before I do this big list, I just want to say the doubled curly brackets here are because we're doing this within an F string. So if we did a single curly bracket, this is what would happen. So imagine we did a single curly bracket within an F string, like if we do just like a variable. See, look, now it thinks that there's like an actual variable, but if we did doubled curly brackets, then it doesn't treat it like a variable because F strings are like good for adding variables into strings, and we do not want that here. So we're using double curly brackets, and then again here we're using double curly brackets. And so the first modification item is the metric. So we have rooms, cleaning, security. The next item is the type of modification. Whenever I type out L by accident like that, I always feel like I'm like insulting myself by accident, or like the computer is like trying to taunt me. So type percentage, I feel like that's like a programming. I guess everyone can do that by accident. So the type is percentage, absolute, set. Those are the different types we're working with. Percentage type is if the bot wants to increase a value by a certain percentage. Absolute is if the bot wants to increase or decrease a value by a specific amount. And then set is if the bot wants to change a value to an exact specific number. So for example, the user might say increase security by 10% today, all day, or they might, for percentage, or for absolute, they might say increase security by 10 staff units. You know what I mean? So then it would do that. Or if set, we could say security must be 20 staff for tomorrow, and then it would do set. So those are the different types that we have. You could do this with other approaches, by the way. You could probably like change the modifications dictionary and do it a different way, however you want to do it, or your business wants it. And then the next item in the JSON dictionary, or this whole thing's a JSON dictionary, but the next item in the modifications dictionary is the value. So that's simple. And then we have just the start date. And remember, we're telling the chatbot, the agent, the LLM, we're telling the LLM to generate stuff in this format. So that's why we have to do all of this. And the reason why we want it in this format is because, as you'll see in a moment, we're going to convert this dictionary to a Python dictionary. And then that allows us to take the modifications dictionary and process it through the rest of the back end, which is how we would edit the forecast. So that's, before we finish this, that's how the LLM is able to modify something else in the application, is that the chatbot response, because we prompted it this way, the LLM is actually going to generate this format, and then the response is the chatbot response, but then it also generates these modifications, which is what we actually need to interact with like the rest of the application. So now we're doing the end date. And then finally we have the reason. So we want it to give a brief operational reason for the modification. And then that's it for the response format. And then just to finish off the prompt, we're telling the chatbot that if there's no modifications needed, it ought to return an empty modifications array. All right, let me end that F string. And this next thing I probably should have done at the beginning of the video, or towards the beginning, but this is, we need to call the LLM model. So let's make sure we do that. We're gonna do a try statement for the regular, okay, so we're processing the message here. So we have the setup for the prompt. What we did so far is we set up the conversation history, which goes into the prompt as the conversation context. And then with using that, we built out the prompt. And so we're doing the process message function. So we need more than just the prompt. So what we're doing next is we're defining the model that actually is used. So the model that I've been using lately is Claude Sonnet. So Claude 3.5 Sonnet. And I've been using 2024 October 22nd is the model version I've been using. You could use a later one if you wanted to. All right, we're gonna give it a max tokens number, 500. The way I look at this is especially like it helps prevent some crazy accident where because this costs money to run. You're gonna have to go, to run this, you're gonna have to go on Anthropic, make an account with Anthropic, and attach your payment method, and you have to buy $5 of tokens. Is, in my experience, that's the minimum spend you have to do to get to use this. But yeah, if you do this, as far as I know, you won't get charged anything more than $5. I kind of like it how you buy tokens in advance at only $5. They don't make you pay like $50 at once, and because some APIs you give them your card and then as much use as happens you have to pay for. That's kind of scary because someone could get your key and use it, or you could just have an accident. And so max tokens helps prevent accidents anyways. Okay, so messages. So this response here is using the Anthropic framework, because self.client, when we remember what the client is Anthropic.client. So that's our client object. So this part of our code here is using the Anthropic framework, essentially. If you want it, it's not really like a frame. Maybe you could call it a framework, but so this Anthropic framework expects these arguments, right? So it expects a messages argument. So that's why we're putting this here. And so we need a role. And then, so this is what's going to go into the LLM when a message has to be processed. All right. And we're still within this try function. This try function is basically the message getting processed. This try statement is the processing of the message. Everything before this was just setting up the prompt, which goes right here. That's what we did here, prompt. We had the conversation history going into the prompt, which goes into the response. And the response is whatever we get from this model based on the prompt. And now we are formatting what comes from the chatbot, the response. So before we formatted the prompt, and now we're formatting the response, which you'll recall is a JSON format. The first thing we have to do is check if the response fits the format that we expect. So we'll store the response, and the response is the content. We store it into this text object here, and then we check that the text matches the JSON format, and we're going to use regex. So this regex search looks for the JSON format. That's essentially what this does. It looks for like the curly bracket dictionary, and it looks for all the lines within the dictionary, as I understand it. Yeah, so that's that. And now, in order to check that we have a JSON match, we're doing an if statement. So this is basically the end of processing the message. As long as we have a JSON match, then we parse the JSON string into a Python dictionary, which is the result object. So now the result object is a Python dictionary. And we're adding the result to the conversation history now. And then we're going to return the result. And that's basically it. So we're going to append the response to the conversation history. And look, if you recall up here, at the start of processing message, remember the first thing we do is we append the user message to the conversation history. So we have role user content message. And so what we do down here is we're appending to the conversation history, but we do like the opposite essentially. So we do role is assistant, and the content is from the result. We have the response, which is the chatbot response. Because there's also the modifications in the result, of course, but we're keeping the modifications as well. So we return the result. So the result, remember, it has the response item and it has the modifications item. So if you look in the prompt, remember we told it to do it like this. So the result is this whole JSON thing, and the response is what we add to the conversation history, but we also collect the modifications. And so this whole thing being the result, what we do is we return the result, and that's essentially the end of processing the message. But there's another thing. There's two things we're going to account for here. So if the result does not exist, then the function continues to its fallback response. And so we're going to do two other types of responses in addition to this normal response. Fallback is one of them, but first we're going to do an exception, an error response. So first we're going to do an error response. So remember that this processing of the message here with the LLM, this is a try statement. So the exception to the try statement is if there's an error. So the exception is stored as E. And we want to print the exception. So this is if there's actually an error. For example, if we're out of tokens with the LLM, or if there's a problem connecting to Anthropic API, there's some other errors that could happen. So we want to print that there was an agent error, and then print the error, which is E. And we're going to record the error response if there is one. So if there's an error, then we'll inform the user, which for this demo, we're just telling ourselves there was an error. So this is specifically for the demo. We would say there was an error during your last message. Please try again. If this was in prod, there'd probably be another way to handle this, probably a more complex way. A simple way would be, contact the helpline or something, contact support, please email this support email. Or there'd be like a more complex way that it gets handled, like maybe it gets sent to a human and then like a human starts talking. There's so many other things that could happen, but it totally depends on the use case. Modifications are empty if there's an error. And then the one other thing we do here is we append. So what do we got? Error. All right, so we can copy this here from the regular response. We have this append thing, so we can copy paste this. The only difference is we want to put this here. We want to do error response instead of result, because remember we have this different object here for when there's an exception. And then we also return the error response, because remember the process message doesn't really give any result. Ultimately, we're using the process message function here, and then we record that, we return the result, and then we use the result, we print the response part of the result, which is the natural language part. And then for the modifications, we would send this to the rest of the backend to apply the modifications. But just in this case for our demo, we just want to print what the modifications will be. So we're getting the result from process message and we're using it further. We're not just printing the result immediately. So that's why, there's like all this extra stuff and we return the result. That's the agentic part of the bot, is that we do more than just get the Anthropic API to say something, All right, and then now there's just one more thing we want to put here before we can actually run the demo. So now we did our regular response. And remember, if the regular response, this try statement, if this fails, then if it fails on trying to get a response from the API, for example, it would then do an exception and it would give an error response. But what happens if it gives a response that doesn't match the JSON format that we have defined here? So what if there's no error that sends it to the agent error thing? And what if there's also no JSON match? So we're gonna also put a fallback response. And what happens is if there's no JSON match here, then it's not gonna return anything here. So then the function would just keep running. And that also, it wouldn't be an exception because it actually ran all the way through. So if this fallback situation happens, then it's not going to return anything from the regular result and it's not going to do the exception. So that's how it ends up with the fallback response. So let's just code that real quick here. So the fallback response would be, I didn't return the expected JSON format. Please try rephrasing your request. That's just the response for this demo. You could have other ways that you handle this kind of thing. But we want to just do a quick standalone demo without any real application of the modifications. Why is this red? Oh. Okay, there we go. And then we're gonna do this append again with the conversation history. But instead of error response or regular response, we're doing fallback because that's what we did here, fallback equals. So we would append the fallback response to the conversation history. I mean, you could potentially just not even append anything, but then it would confuse the bot because it has that history of the message it had to process already. So you might as well append the fallback response into the conversation history if this is the case with the fallback. And that's really it there. So we can move into the demo now. There we go, just cleaning that up real quick. So just a quick scan. We're importing libraries, we have the class, and it processes the messages. We've ran through that quite a lot. And now we have the demo. The demo is ready to go. So let's run this thing. All right, if you're following along, I actually made some typos here at line 57. Self.client.message.create, we want to do messages, not message. So it's a plural messages. All right, another thing that I have to fix is the conversation history append. All three of these, I put an extra colon after role. So if you followed along exactly, we want to fix those three. The last of the three typos I made was the very last line. We need the empty parentheses after demo chatbot because it is a function. So I want to make sure I get this across before we advance more with the demo. I added more max tokens. So I'm doing 5,000 max tokens because the agent needs more breathing room in order to handle longer conversations with a big conversation history. Another change I made is I changed start date and end date to date time, and so now it includes hours because it's an hourly forecast. It needs to handle hours, and I also made that same change here with the start date time and date time instead of just date, it's date time. With those changes now made, let's run the demo. So this is the Docker image, very basic. I have a requirements file for those libraries we imported, exposing the backend server and just copying the file we just made, and it just runs that file. All right, so let's first build the Docker image. I have Docker desktop running. So we're building this with Docker desktop. Now that the image is built, we can run it. So we're doing Docker run -it because it's an interactive in the command prompt. And then we call the port 8567 is the server. And then we call our environment file, which is the .env file. All right, the .env file looks like this. So it's your Anthropic API key, and you would put your key here. Don't use quotation marks, just put it like that. And you would make it .env. So forget the .example part, and that's your environment. So we call that here. And lastly, we call the app name from when we built the image. There we go. So the demo is running. So first we can say UFC fight Saturday. There we go. So there is a major UFC event expected this Saturday. The bot says 6/28. Today is, as of recording this, it's June 24th. So June 28th is this Saturday. So driving significant increases in occupancy and staffing needs. High-profile fights typically bring large crowds requiring extra security presence, especially around event times. Extra cleaning staff needed. All right, the UFC fight. So expect peak activity 12 hours before and after the fight. So the first modification is rooms 25% increased. We have Friday at noon to Sunday at noon. We have weekend peak occupancy for the UFC event is the reason. And the next metric is security. We have a 40% increase for Saturday noon to Sunday 4 a.m. So you can imagine the casinos and other parts of the property after the fight should have higher security staff. And then cleaning, we have increased guest turnover and public area maintenance, so higher cleaning staff for Saturday 8 a.m. to Sunday 4 p.m. And so another thing we can say is there's a tech convention Wednesday to Thursday. We could give it specific times, like 5 p.m. It ends on Thursday, and it would give us 5 p.m. But I forgot to do that, so let's just let it run. So it gives a chatbot explanation. This is what the user would see. Remember that the user would see this explanation, and then the modifications would be made to the forecast that the user's looking at on their screen. So just for the standalone demo here, we're looking at the modifications. We don't actually have a forecast connected to this, so we're gonna look at the modifications, but the user would only see the bot message. So the bot message discusses the tech convention Wednesday to Thursday, talking about business travelers requiring midweek accommodations and meeting spaces, increased room occupancy Wednesday to Thursday with standard business hours activity, additional cleaning for meeting rooms and public spaces during convention hours, moderate security presence required for credential checks and equipment protection. So we have room occupancy increase of 85% for tomorrow is Wednesday at noon to Thursday 11 p.m. Tech convention attendee accommodations. We have cleaning increased by 30%. We have security increased by 15%. Now what if we say it's an extra rowdy tech convention? We need more security than that, slightly more. So for the extra rowdy tech convention, the bot says, adjusting security staffing levels upward for the tech convention due to reported rowdy behavior expected. All right, and then it also says this overlaps with the already heightened security needs for the upcoming UFC event. So the bot is clever, a smart little bot mentioning potential overlaps between these two events we've already told it about. But here we see the 25th to 26th. So again, it's Wednesday to Thursday. It's essentially the same times we've looked at before. Security is now increased by 25% for elevated security needs for the Rowdy Tech Convention. And now let's tell it to summarize the changes we've made so far to the forecast. And if we had max tokens at 500, it would probably give an error on this message. But because we gave it that breathing room, it was able to generate this summary. So the bot says what the user would see in this case would be current forecast modifications include 1, UFC fight, and then it gives the date, it gives driving peak occupancy, increased security cleaning needs. 2, tech convention Wednesday, Thursday, requiring business accommodations, elevated security due to rowdy behavior expected. Both events overlap, creating compound staffing needs, especially for security. We have the list of all of the modifications. So the thing is, in the application, we could, for example, at the bottom of the web page or in an extra tab, we'll have the change log of all of the modifications we've made. So here it just gives all of those modifications. But of course, the actual prod version wouldn't put this in the chat panel for the user to see. The user could view it in a change log specifically designed for these changes to be listed. So that's what we have for the demo. That's really it. I hope you got something out of this and enjoyed coding along with me if you put in that extra effort to code it yourself. The low-level work to understand how agents can do more than just talk to someone with the large language model, but can also be packaged in a way to deliver things like through a Python dictionary to make changes outside of the chat, but actually do things, for example, edit a business forecast, interact with other machine learning model results or other models in general, or also like send an email or do another process automation. So remember, of course, chatbots, the AI agents, they're more than just chatbots. Large language models are more than just chatbots. Like, they can do things, and their results can be used to do things like managing a business forecast. And so this was just a standalone demo, but here we see what is possible. The amount of code that we needed for this demo was 128 lines, and that's it. So just to summarize, we imported our libraries, including the Anthropic library. We created our forecast agent class, which initializes with the Anthropic API key and a conversation history starter. We made our process message function, which initially adds the new message to the conversation history and then uses its conversation history to build context for the prompt, and then puts that conversation context into the prompt. And we designed our prompt with context of today's date and also what the forecast is about and what it's forecasting. We gave it examples of prompts, we gave it examples of messages that it would have to respond to. We gave it the format it needs to respond in, including the chatbot message, and also the LLM additionally creates the modifications dictionary. And what we did was we took the response, we give that in prod, we give that to the user, and the modifications can show up in a changelog for the user, but the modifications are really what needs to be pipelined through the back end to affect the changes that the agent is really designed for. We declared the LLM model that the chatbot agent uses, which is Claude 3.5 Sonnet. We gave it enough breathing room with the max token so that it can handle summaries of the forecast. We have it check for the proper JSON format before it adds a message to the conversation history and uses that message. We have it check the response for the proper JSON format before it uses the response. And if it doesn't fit that format, well, if there's an error with the chatbot or something like that, then it would give an agent error. But if it doesn't fit the JSON response, then we do a fallback response where it asks for another request, or we could handle that in a more complex way in prod. And then we designed our chatbot demo, which was a way for us to look at how the chatbot runs using just our command prompt with a basic Docker image, so that we can get an experimental idea of how it would actually be useful in prod for the application. And we ran our demo. We ran the demo. So thanks for following along. I hope you got something out of this. Have an awesome one. And remember, let's build cool things that help people. All right, love y'all. Peace out. Bye.